Hello, everyone, and welcome to the first A Cloud Love session from Dev Team. I work as a cloud solution architect by A Cloud Dev Team, and I'm really happy to have you here. So today we're going to have a hands-on about decoupling with microservices on AWS. Let's get it started. Let's have a look at the agenda. Our first step is just to have a look at the introduction, quick introduction. After that, we're going to containerize the monolith application and deploy it to AWS. We're going to break the monolith application into microservices, and we're going to have a look at the benefits of microservices. For sure, we're going to have a Q&A session after that, where you are more than welcome to ask your questions. Let's get it started. As for the introduction, this lab is actually based on the AWS lab, and you can find it here. It's called Break the Monolith Application into Microservices. It takes about 2 hours. That's why we're going to finish it in 30 minutes to speed up the process. But if you have time, I highly recommend to follow this. And also we have a GitHub a repo where you can find the source code. This is the GitHub repo source code, and here you can find source code of the application, Docker files, CloudFormation stack, and other information as well. And as for the AWS experience, it is about intermediate, but don't worry, I will try to explain everything what I do. And time we need for this lab for my lab is about 30 minutes. We're going to deploy simple monolithic Node.js application using a Docker container. And for this, we're going to use Elastic Container Registries to store images, CloudFormation to automate the process of creation of infrastructure, Elastic Container Service, which is a highly scalable and fast container management service, and some others. After that, we're going to decouple the monolith application into microservices and change the underlying infrastructure accordingly and see the benefits of microservices. Sounds great. So uh, yeah, we're going to containerize the monolith application. For this, we need to build container image and just to push it into Amazon Elastic Container Registry. But first of all, let's have a look at the application architecture. On the left-hand side, you can see the monolith. This is one container we're going to build, and one API service with 3 features, which called users, thread, and posts. And we're going to split it after that into 3 containers, into 3 services: user, threads, and post service. And if we go to the source code and choose the to containerized, we can find here services API. And here, this is the folder for our monolithic application. Here you can see the source code and also Docker file. Docker file is pretty simple Docker file. One thing I would like to draw attention that this container is going to export port 3000. And if I get back to the API, also I can see here db.json file, which help us to just to have data for users, feature, threads, and post, all data in one file. All right, so let's do this. Actually, just yeah, I've just decided to save our time and already done this in advance. And for this, I use the following commands. First of all, I create the repository called API. And for my laptop, I used AWS CLI to log into the Elastic Container Registry. After that, from the folder, I built the image with the tag API. And after that, I tagged the API image with tag from the Elastic Container Registry, version 1, and just push it to the Elastic Container Registry. So if I go now to the Elastic Container Registry, I can find the API repository. In this API repository, I can find v1 image tag. And this image URI I can use right now in my configuration. So let's move on. And our next step is to deploy the monolith application. We already have container, which is in the Elastic Container Registry. And now we're going to create the infrastructure on AWS with help of CloudFormation. And after that, we will configure Elastic Container Service to run the application. I would like we to quickly have a look at the architecture. At the architectural view here, what we're going to do, we're going to create load balancer, target group, and behind this target group, we have a target. This is monolithic application in container. So as I said, we're going to use CloudFormation, and CloudFormation stack can be found here in the infrastructure folder. You can find elastic container service.yaml file, and this has everything that you need. So that's why we can simply go to the CloudFormation service and click on the create stack, and we can choose the file. This is the file we just saw. Upload it, click next, name it a cloud loft, and use the default parameters. Click next, scroll down to the very bottom. Just need to tick it because we're going to create some roles, and click create. So on the left-hand side, you can see the status of this CloudFormation stack. It is create in progress. Meanwhile, it is created. We can check the template. The template is already here. As for the parameters, the first one, this is the desired capacity. So desired capacity of instances. We use, as I mentioned, Elastic Container Service, and we use EC2 launch type. It means that we need to configure and deploy EC2 instances in our Elastic Container Service cluster. And on these instances, we are going to run our containers. And here we just specify how many instances we would like to have. It is 2. Max size of instance will be also 2. Instance type, we're going to use, we were using default one, T2 micro, but based on your workload, you can choose whatever you like. As for the AMI, we're going to use the ACS optimized AMI, which already has Elastic Container Service agent. And if we click get back to the parameters here, we can see that this value was resolved and we have a specific AMI. So, sorry, get back to the template. And our next step is to have a look at the mappings. You can see that we have a CIDR for VPC, we have a CIDR for public subnet 1, and we have a CIDR for public subnet 2. So, and now we can move on to the resources. As I mentioned, we're going to create virtual private cloud. And in this private cloud, we're going to create 2 public subnets, the first one and the second one. This is, as I mentioned, this is a public subnet. And for this, we need Internet Gateway. That's why we create Internet Gateway and create a gateway attachment to the VPC, right? And also we need root table. And in this root table, we're going to create a root. And it says, okay, if the destination is internet, just use the Internet Gateway. And to make it work, we also need root table association with public subnets. We need it for public subnet 1 and for public subnet 2. And now we can move on to the Elastic Container Service resources. Yeah, and the first one, this is the Elastic Container Service cluster. Also, we need a security group with some inbound rules. The first one allows port 80. The second one allows port 22. And the third one allows ephemeral ports from 31,000 to 61,000. And also we're going to create a CloudWatch low group. We will create application load balancer, and it will be internet facing. That's why you can see here we have 2 public subnets, and we are going to put our EC2 instances into autoscaling group. And for this, we need to create launch configuration. In the launch configuration, we specify which security group we're going to use, which instance type, and also we can specify user data. In the user data, actually, this line helps our instance to join Elastic Container Service cluster, because here we say, okay, just save environment variable name of Elastic Container Service cluster in the ECS configuration. And as I mentioned earlier, we're going to create some roles. The first one, this is the Elastic Container Service role. The second one, EC2 role. And the third one, autoscaling role. And also we have a resource called instance profile, EC2 instance profile. We need this to just to assign the role to the EC2 instance. And we have some outputs. Outputs help us to quickly get data, for example, about the VPC ID, and also we can use these outputs in other CloudFormation stacks. So great. You can see that the status of the CloudFormation stack right now is create complete. It means that all resources have been created successfully. We can see it here. We can see here resources. Yeah, create complete. And we can see outputs. And here you can see VPC ID, URL of the application load balancer, and others. And now I would like we to move on to the Elastic Container Service. Go to the cluster, refresh your page, and here you can see a Cloud Love Elastic Container Service cluster. And if I go here, Elastic Container Service instances, it is the EC2 launch type. That's why this cluster has two instances, and they are in different availability zones. And now we can put our workload on these instances, right? So for this, we need to go to the task definition. Task definition is required to run Docker container in Elastic Container Service cluster. If we click on the create new task definition, we can specify the launch type. In our case, it is EC2. And now we just name our task definition, or name it API. Go to the add container. We're going to add container. We're going to name container API, and now we need image. Image, we can get it here. Repository API, just to copy it and paste it here. Also, we can specify the memory limit, hard limit, and we need to set the port mappings. Port mappings allow container to access port on the host container instance. So that's why on the right hand side we can see container port, and as you remember in the Docker file we exposed the port 3000. And as for the host port, I'm going to set it to 0. It means that I'm going to use dynamic host port mappings from the ephemeral port range we specified in the security group. And now I move on to the next settings, the CPU units. I'm going to set it to 256. Click Add, scroll down, click Create. And now I have a task definition. This is a description of my, so to say, container. And now we need to go to the EC2 service and check load balancers. We have a load balancer. As I said, this is the application load balancer. It is internet facing. We don't have any listeners so far. That's why I need to go to the target group and create a target group. This is the default settings. Now I just name it API. I need to choose the right VPC, in which VPC, and click next. I don't need to check anything here because our target will be containers, not instances. I click create target group, and now I have a target group called API. So now I can go to the load balancer and create a listener. Listener, this is the process which checks for connection requests. And if I get a connection request at this protocol HTTP port 80, I would like to forward this to the right target group. And this is my target group API, and I just add it. Now I'm done with a load balancer and can back to the Elastic Container Service. Now I need to go to the clusters, and I need to go to the here, and I have a service. Service helps me to run those tasks on the Elastic Container Service based on the task definition. For this, I just need to click create. I need to specify the launch time, which is EC2 in our case. Task definition. I'm going to use API task definition I've just set up. I'm going to name the service API for simplicity. And how many tasks, how many containers I'm going to run? In my case, 1. I need to click next. And as for the load balancer, I'm going to load balance it. And I already have load balancer and need to click add to load balancer. Here, just specify the right listener. And as for the target group name, I just choose API. It means that when the task is created, it will register with this target group automatically. And click next, and quick review and click next. Great. We just need to wait some seconds. It's pretty quick actually. And yeah, we can view service. If I get back to the cluster, now I can see that I have service right now called API, and it is active. The desired number of tasks is 1, running 0. For this, I need to wait some seconds, and you can see that running task is 1. And remember about the registrator with target groups. If I go to the target group right now, in the API target group, I'm expecting to see one container. Right, it's one container. This is the dynamic port, and it says healthy. Great. So now if I get back to the CloudFormation and copy this DNS of the application load balancer, put it here, add API users, for example, I'm able to see data from the DB.json file. And also if I choose threads, for example, yeah, it works. So great. And what it means that right now we have just give me a sec. It means right now we have a load balancer target group, and one target is registered, one container is registered with this target group, and I'm able to get access to this container. But what happens if this task container goes down, if it's not working, if it's crashing? So I can just do this by going to the task, and here there is a possibility to click on the choose the task and click stop task, click stop, and get back to the to this page, and service is unavailable. It makes sense because the container has been stopped. If I check the users feature, it's not working. If I check threads feature, it's not working. And if I check post feature, it's not working either. So it means that monolithic application doesn't have isolation of crashes. It means that if container goes down, all features go down. So it's not really good. And thanks to the service, the task has been restarted, and now it is available. And what I would like to do next, let's imagine that these users, get me back here. Let me go to the application overview, and let's say if the feature users need more resources, for example, it receives more requests, and for this I need to scale, for example, scale the number of containers, right? And if I do this, I will scale container for every feature, but maybe I don't need this for threads. How I can do this? If I go to the service, go to the API service, and go to the update, I can change the number of tasks, right? And click next tab, next, and update service. And if we quickly check the status of the service, it says, okay, desired number of tasks is 2, running task is 1, still 1. We need to wait some seconds. Okay. Okay, so yeah, we were able to scale up our container for monolithic application, but it's not really efficient, right? Because we scale up this container for other features. So it means we couldn't do this independently for the feature. And I would like we to move on to the next step, and now we're going to break the monolith. We're going to create a container for each feature for each service and push it to Elastic Container Registry. As I already said, I've just decided to save our time and done this in advance. It means that if I go to Elastic Container Registry, I already have all those repositories for users, thread, and posts. And aside of them, I have version 1 of this image, and I can use them right now. But I would like we to quickly have a look at the source code. Where I can find these microservices. If I go to the Amazon ECS Node.js microservices, I need to go to the folder free microservices and go to the services. And here you can see 3 folders: users, threads, and posts. And each of them has a Docker file and source code. Docker file is absolutely the same. Port is 3000. But if I check the db.json file, I will able to see the difference. Now I only have data for users because this is the users service. If I go to the threads, I will be able to see only the data for threads. So as I said, I've already done this. We have all images in the Elastic Container Registry, and it means we can move on to the next step. Now we're going to deploy microservices, right? And we're going to deploy it as a set of services behind application load balancer. And here we can quickly have a look at the architecture. What we're going to have, not here, here. So we're going to have load balancer, but now we're going to add additional target groups. And behind of the target groups, we're going to have targets, 1 container per service. And now it's high time to get back to the Elastic Container Service and create task definition for our new services. So we click on the create task definition, our EC2 type, click next, name it now, right now users, and go to the add container. Container will be users as well, but now we need to find the right image. Repository users, just copy it and paste it here. We specify the hard limit is the same. Port mappings, they are absolutely the same. 3000, I set it to 0 because I would like to leverage the dynamic host port mappings. And CPU units, 2056 as well. Click add, scroll down, create. Yeah, we get back to the task definitions, and we need to create task definition for threads and posts as well. I will try to do this pretty quickly. So threads and add container. Name of the container would be threads. Threads, and we need to find the image. And this is here. Go to the version 1, copy it and paste. So the hard limit, I'm going to use the same. Port mappings, absolutely the same. And CPU units, also the same. Click add, scroll down, create. And the last task definition we're going to create called posts. So EC2 launch type, task definition, we're going to call it posts, and go to the add container. We'll name it posts. Image, we need to get back to repositories, and we need to find users. Oh, not users, sorry. We need to find posts. And here, go to the version 1, copy it, and paste it here. Specify the hard limit. Port mappings is the same. And one last step, we need to specify CPU units. Click add and click create. Right now, we have task definitions for users, threads, and posts. I'm going to create another task definition for default rule in the application load balancer, which I will call drop traffic. Oh no, sorry, this is like not, it's not right, sorry. Yeah, I've just created task definition. Now I'm going to go to the uh, target groups. I'm going to create target groups for our services, and it will be target group for users. Don't forget to choose the right VPC we've created. Next, create target group for users. Also create target group for threads. Choose the right VPC. Click next and click create. Another target group for posts. Choose the right VPC and click next and click create. And here in the target group, I'm going to create another target group called drop traffic. I'm going to show you why I need this in some seconds. And create target group. Great. Right now, I can go to the load balancer and change my listener. I mean, I would like to edit rules in my listener. So here you can see that we have a default rule, and it's like forwards traffic to the API target group. And I just want to change it a little bit. I just want to add path, like just if the request is using the path API and everything, just forward this to the API group. If the path is API users, forward this to the target group users. The next one is if the path is API threads, forward this to target group threads. And if the target path is API posts, forward this to target group posts. And here, now what I have right now the rule. This is the first rule, and all traffic will be forwarded to API right now, because I need this to switch the traffic without any downtime. I will going to remove it later. And what I'm going to change, also I'm going to change the default rule. I'm going to delete this and action forward this to the drop traffic, because as soon as I remove monolithic application, I don't want traffic is forwarded there. So great. Right now, I have listener with right rules there. All traffic is forwarded to the monolithic. And now I can go to the Elastic Container Service and go to the cluster, and I can create services. I can create services for users. So EC2 launch type. I can create services for users, and I will name it users. How many tasks I'm going to have? One. How many containers? Next step, I'm going to load balance it using the load balance I have. That's why I need to set up contain to load balance settings. I'm going to use listener, and I'm choosing here users. It means that when the task is created, this task is going to be registered with specified target group automatically. Next step, and create service. So just need to wait some seconds. And And I can click on the view service and go to the cluster and create additional services. So easy to type as usual. Now I'm going to use that definition called threads, and the service name will be threads. And number of task 1. Scroll down. Next, I'm going to load balance it, and for this I need to choose the listener, and I would like this task to be registered with threads target group. Click next, create service. Another some seconds and we can continue. Right, click on the view service and go to the cluster. And another service I want to create called posts. So easy to launch type, post target definition called posts. Service name will be posts as well. And the number of tasks of this in this service will be 1. Click next step. I want to load balance it as well. And I need to make some changes here. I'm going to use listener of the load balancer, and I would like this task to be registered automatically with post target group. Click next, overview, and click create service. So let's just wait another seconds, and it's finished. So get back to the services overview. And here you can see right now that I have 1, 2, 3, 4 services. API says this is a monolithic application, 1 container with 3 features, and this is the separate services per container, users, threads, posts. And you can see that the number of containers, like 1 second, and we can see that we have 3 containers right now. And if we check right now target groups, we have to see containers which are registered as targets with specific target group. It's great. And now what we're going to do, we're going to switch our traffic. If you remember, we have a rule which forwards right now API, everything to API group. It forwards to the monolithic application. So when you just check it, it goes to the monolithic application. To switch the traffic, I'm going to remove this rule, right? Delete. And now, if I just use API users, it will forward to the users target group and accordingly. And if I do it right now, for example, users, now I'm using my microservices container. So, and get back, and let's get back to the presentation. Our next step is to have a look at the benefits of microservices. You saw with the monolithic application that it wasn't possible to isolate, to make an isolation of crashes. But with microservices, if I go to the services, and if user's service or if user's task is not working, I can do this by going to the task and choosing the task, and I can choose, say, okay, just stop this task, stop this container. And now if I check this here, I can see that my service is going to be unavailable. But because we have the microservice architecture, our threads is working and our posts are working as well. Yeah, so it's great. It can just it doesn't influence other services in our microservice architecture. And also, as for the other benefits, is independent scaling. Yeah, and as I said, for example, if I get to the Elastic Container Service and have a look at the services right now, let's say, I don't know, posts, for example, need more resources. This service has more requests. And by using microservices, I can independently scale up and down. In my case, I'm going to scale up. I'm going to update this service, and I'm going to change the number of tasks from 1 to 2. And just next step, next step, next step. Overview and update service. And you can see that it's pretty quick. And if I just update it, in some seconds, I have to see another container behind my post service. Let me quickly check the service. If I go to the task, to the events, I'm going to check what's going on. Okay, get back to the services. And yeah, great. So you can see that my users and threads have only one container, but posts, for example, can be scaled up and scaled down independently. It's really good feature of the really good possibility of the microservices, where we can save resources and just add resources to the service where it is necessary. Also, another benefit of the microservice is isolation for security. For example, if we're talking about Elastic Container Service, and we can say that, okay, for which service I can specify IAM role, and this service has access only to specific resources. If it happens that anyone get access to this service, it just get access only to the resources of this service, and it doesn't impact any other services. They need to attack other services. So as for the other benefits, this is the development velocity. Like microservice helps really just speed up the process of development. So it means if you just create a new service, you just write a new code, your developer is not afraid of adding new code, because it doesn't impact any other code, because they're separate until for sure there is no connection between those services. So this is actually what I wanted to show you today about the microservices, and this is the high time to ask your questions. Thank you so much.